Hello everyone. Previously we had discussed on the topic advanced exception handling, right? So today we'll be discussing on the descriptors and memory optimizations topics, right? So here now, what is the let's get into the definition part first. So here, what are descriptors? Let's see first. Descriptors are the Python objects that customize attribute access by implementing the methods like get, set, and delete. Right? So here again, so just keep this in mind. This is very important. So descriptors are Python objects that customize attribute access by implementing methods like get. What are the methods here? Get, set, and delete. Right? So they allow fine-grained control over how class attributes are managed and can be used with the slots. This one, slots, to reduce memory usage. So this is about the descriptors along with the memory optimization, right? So let's get into the example part. So before getting into the example part, let's discuss quite a few points, man, here, right? So uh, a descriptor is a class that defines one or more special methods like get, set, or delete. We know this from the definition as well. This is very important part. Just keep this in mind, right? So these are automatically triggered when an attribute is accessed, modified, or deleted. When they're triggered, these are automatically triggered when an attribute is accessed, modified, or deleted, right? So Python's built-in features like at property, static method, and the class method, we have already discussed on the this one, a static method and the class method, right? So Python's built-in features like at property, static method, and the class methods are built on the descriptors. They are built on the descriptors. Just keep this in mind. When combined with slots, descriptors help prevent dynamic memory allocation for this one unused attributes, making instances memory efficient, right? So this is it for the descriptors on the memory optimizations part, right? So now let's get into the example part. I'll just go with a very simple example here. I'll just go with class descriptor. So this is fine, class descriptor. So next, let me get into the uh, init. So here, just give me a second. Yeah, this is fine. So I'll just go with self dot name. Let me initialize this one to name itself. So this is fine. So we are just what we are doing here, we are just storing the attributes name that needs to be controlled. Line number 14 I'm speaking of mainly. So now let's get into the get and set. So here, accordingly with the definition, so descriptors are Python objects that customize attribute access by implementing methods like, what are the methods here? Get, set, and delete, right? So let me go with the get first. So let me go with def, sorry, so which one did I copy, man? This one, right? So let me copy this one, paste it over here, def get. So let me go with self along with the instance and the parameter owner. So this is fine. So within the get, let me print something for the interactiveness. So I'll just go with the print. So this one will be getting self dot name. So this is fine. Self dot name. So this is fine. So let me come out of this one entirely. Let me return something here. Return instance dot. So let me go with a dictionary here. Dict. So I'll just go with dict. So this is fine. Within the array we have to go. So we are returning the value from the instances internal storage, right? So I'll just go with the self dot name here. So I'll just go with self dot name. This is fine. Yeah. Next, we are done with the get method. We are done with the get method. So let me copy the same for the this one. What do you call? Set method, and let me make the necessary changes here. So instead of the get, I'll just go with set here. Sorry, set. This is fine. So this will be same thing. Instance, instead of the instance, I'll just go with the sorry, instead of the owner, I'll just go with the value. Right. So I'll just print. Instead of getting, I'll just go with f followed by. So here we are going with a setting, right? So instead of the get getting, I'll just go with the setting here. This will be same. Self dot name, this remains to same. So we have considered this one as well, right? So what do I call value as well? Let's pass value as well here. So this one will be to value. So this is fine. Now this remains. We don't have to return anything, man. We don't have to return. We don't have to make use of the return keyword here. So this one will be instance dot dict. So this remains same. Self name. This one, let's assign this one to the value, right? So let's assign this one to the value. So what we are doing here, basically, we are assigning the value. We are assigning the value into instances internal dictionary. In instances internal dictionary. That's what we are doing. So next, let's go with one more class here. Let's go with one more class, simple class. So let me go with just give me a second here. Let me do one. Yeah, let's go with a class person here. So this is fine. So let me make this one capital P man. So this is fine. Next, what shall I do? So I'll just go with the slots here. This one somewhere. Yeah, this one slots, right? So let me copy this one, this keyword. So here they allow fine grained control over how class attributes are managed and can be used with a slots to use the memory usage. So we are going with a memory optimization part, right? So by making use of the descriptors basically. So let me make use of the keyword slots here. Let me paste it over here. Sorry, just give me a second, man. Let me copy this one. It's fine. Yeah, let me paste it over here. Slots. So this one equals within the array. Um, Let me go with dict actually, dictionary. This is fine. This has to be called within the single inverted comma. So I forgot the single inverted comma here. Just give me a second. 1 second. Yeah, this is fine. Yeah, we are just restricting the memory allocation to only existing attributes. So this is nothing but the optimization part, right? So we are just restricting the memory allocation to only existing attributes, right? So by making use of the slots keyword, this one, right? So here what we are doing here, we are restricting the memory allocation to only existing attributes. Just keep this in mind. This is important. What we are doing, again, for the third time I'm stressing on it, we are restricting the memory allocation to only existing attributes, right? Let's move on with the further things. Now let me consider name and let me assign this one to the descriptor name. So this is fine. Name. So name is managed by the descriptor. We know this one, right? So we know this one. So next, let me go with def init. This one will be self and name. This one will be self and name. So this is fine. Now let me go with self dot name. This one will be equal to name. So this is fine, man. Basically, this triggers the descriptor dot set. This triggers the descriptor set. This one, right? So we are done with the coding part, almost, right? So one thing we have to do here is we have to create the instance, right? So let's create the instance and let's print something, man. So here, let me go with a variable name p. We are creating the instance, right? So the class name is person. So I'll just go with a person here. So name, we are going with a name equals name here, right? So this one, let me provide the name Bharadwaj here. This is fine. And also let me go with print p dot name, p dot name. So we are done with the code. So let me format the code once. This is fine so that this looks good. So what we need to do here, basically, sorry, what is the output that we need to get here as this one. Yeah, setting self dot name we have given, setting name, self dot name is nothing but name, setting name to value. What the value here, what is the value here? Value is Bharadwaj. We have set the name to Bharadwaj. So we have to get the output setting name to Bharadwaj. Also this one get, also we have made use of here. So this one we have to get getting name. That's it. Getting name along with a Bharadwaj. We are just printing this one p dot name here, right? So p dot name is Bharadwaj. So overall we have to get the output in 3 lines. One is setting name to Bharadwaj, and second one is getting name, that's it, and the third one is this one, what do we call, Bharadwaj. So let's try running the code. I hope we get the correct output, man. Let's see. Let me copy the file name here, paste it over here, dot py. So we are getting the error, some error, right? So what does it say here? Init takes one positional argument, but two were given. Where? So init we have made use of here, right? So line number 27. Name equals descriptor of name. This is fine, right? Name is managed by the descriptor. So name equals descriptor of name. This is fine, right? So what I'm doing wrong here? Just let's see here. 25 as person. So what this is saying here? Descriptor.init takes one positional argument, but two were given. So init part, yeah, we are considering name here, right? So let me add name along with the self here. Yeah. Now let's check this error has to go away. Let's see. And here I have given f. We are going with a string interpolation, right? So let me add f here. So this is fine. Now this has to give us the correct output. Let me give clear screen here. Yeah. Now we are getting correct output. It's setting name to Bharadwaj and it getting name. So this is fine. This one Bharadwaj, right? So we are getting the correct output. We are getting the correct output. So here I'll just remove it. So remove it, this one setting. So let me run this one again. So this we are just giving in the string, right? So setting name to Bharadwaj, getting name and Bharadwaj. So this is fine. So this works absolutely correct. So let me explain. Here setting name to Bharadwaj, whatever the output that we got here, the first line here, this one. So basically the set method in the descriptor. So this one I'm speaking of, the line number 20. The set method in the descriptor class is called when self.name equals name is executed inside the constructor part, initialization part. This one I'm speaking of, right? Self.name equals name is executed inside the constructor. So it prints the message before storing the value. This we know, right? So let's go with a getting name here. Getting name in the sense this one, get keyword, right? So here the get method is triggered when print of p dot name is called. This one, the line number 34 I'm speaking of, print of p dot name is called basically. So what it does, it prints the message before returning the value. This we know. And about the Bharadwaj, whatever I have given here, the last output, so this one I'm speaking of the Bharadwaj. So here the final result, yeah, the final result of get is returned and printed. Bharatwaj, we are getting the correct output, right? So this is about the descriptors and memory optimization. So descriptors comes with the two keywords, mainly get set, right? So get set, also delete. So this is fine. And also for the memory management, we'll be making use of the slots. I have stress this one. So basically they allow fine grained control over how class attributes are managed and can be used with the slots to reduce the memory usage. We have successfully made use of the slots here, right? So this is fine. I hope the concept of descriptors and memory optimizations are completely clear. Now let me summarize whatever we have learnt so far, right? So descriptors give full control over how attributes behave. We know this. They are reusable components, that is that are useful for the validation, access control and computed properties. This we know. And when used with the slots, this one I'm speaking of again, when used with the slots, they restrict dynamic memory allocation and reduce the memory usage. The final one is this technique is ideal for memory optimization and large scale or performance sensitive applications. Right? This technique is ideal for memory optimization in large scale or performance sensitive applications. Just keep this in mind. So this is it for the descriptors and memory optimizations, right? So next we'll be discussing on the topic this one. What do we call? Abstract base classes. Sorry, Next we'll be discussing on the topic abstract base classes. For now, this is it. Thanks for watching, guys.